students. Thank you for joining me today. Today we're going to be taking a look at working with the arc sine. Now the arc sine is a little bit different, and that's because of the way the arc sine works. Now, I started to talk about this in class, but I'm sure that a lot of people didn't understand it. So what I'd like to do is I'd like to go over it with you again. If we're looking at a sine function, the sine function oscillates like so. Now, if I'm trying to draw an inverse, I got a little bit of a problem because it's going to go up and curve and down and curve. But that's not a function. It fails the vertical line test over and over and over again. It forces us to restrict our domain. So what we're going to do is we're going to go to the low point before it starts to repeat itself. And then we go to the high point before it starts to repeat itself. And this stops right down here. So this is our -1 at -π/2. And we have a +1 on this side at π/2. So because of that, our calculator will only work with the positive quadrant, or the opposite of the positive quadrant. See, it's this part right here, from here up to here. And that's what we end up working with. The problem with that is, that means that our calculator, whenever we work with sine, we have two possibilities. If I have a sine of an angle equals a number, if the number is greater than or less than 0, let's start, then I will always get an answer with my calculator in degree mode that is between -90 degrees and 0 degrees. If the number is greater than 0, I'm going to end up with a situation where my answer will have to be between 0 degrees and +90. Now, because of that, I am forced to go back to that silly reference angle stuff. And I can't stress it enough that it always comes back to the reference angle. And if I end up having a negative sign, I'm going to get an answer that's down here, and I have to find this second one. And you'll notice that if I move these two things around, my theta prime, which is what I'll be given, is just 180 plus theta prime to give me theta. Okay, so that's what I'm going to end up doing. All right, here we go. We're going to do a few of these so that you get the idea. All right, please don't get upset. Stay patient, stay calm, and please make sure you're in degree mode. All right, let's just make sure. Degree mode means that I hit mode. And once I have mode, I'm going to bring down the cursor, and I'm going to move over onto degrees, and I hit enter. That's going to make sure that the box, the little black box that we have around the word, is around a degree. That's how I know it's set. We're now going to go to our home screen. Now, in order for us to do this, we have to work with the arc sine, that second function sine, and we would then put in whatever ratio is given to us. So if we were trying to do the sine of theta is 0.5032, I'm going to say theta equals the arc sine of 0.5032. And this is what I'm going to put in my calculator. So let's do that now, please. Here we go. 0.5032, enter. Now remember, this was a positive ratio, so the answer that we get is sitting right here in the first quadrant. And the answer would be our first theta is approximately 30.2119, and don't forget your degree symbol. We're now going to have to go into our third quadrant our second quadrant in order to find our second positive angle. Once again, Sine is positive in the first and second quadrant. The second quadrant uses 180 minus theta equals theta prime. And if we move things around, we have, after all, our theta prime. I can say it's 180 degrees minus theta prime will give me theta. Since I already have my theta prime, 30 degrees, I am simply going to go 180 minus my answer. When I hit enter, I get my second solution, 880. And that's what I'm going to write for my theta number 2. Notice there are always two angles that we're going to find unless they are quadrantal, sitting on an axis. 149.788, and I like to truncate, but you can either truncate or round. And there's my answer. Let's go ahead and go to another one. This time, let's do a negative. So we're going to look at the sine of theta is equal to negative 0.3115. So we have theta equals the arc sine of negative 0.3115. With this, we can now use our calculator. Now we know we're going to get an angle degree that's going to be between negative 90 degrees and 0 degrees. It's a negative answer. We know the quadrants that we're working with are the quadrant 4 and quadrant 3. In quadrant 4, we know that we're going to take 360 and we're going to add our negative theta prime. In the fourth quadrant, we're going to have to do 180 minus negative theta prime. This will give us the double negative so that we end up adding them together. Here we go. So we're going to put it into our calculator exactly as we see it. So second function sine, that's second sine of negative 0.3115, close, enter. Notice there's our negative and our negative degree. We expected that. So if I wish, I can store it in alpha A so that I can use it more than once. Now I'm looking at 360 plus alpha A, and there's my first answer in the fourth quadrant. In the third quadrant, I have to take 180 minus alpha A, and I get my answer in the third quadrant. These are now the two solutions that I'm trying to write. We're going to put them down as 341.8503 degrees, and then we're going to have, the other one is 198.149, and I'm going to call it a 6 degree and just truncate. And these are my two answers. Let's try another one. Let's take the sine of theta is equal to negative 0.4566. I'd like you to take a moment and see if you can get this. Once again, working with your calculator, first find the arc sine button. Then put in negative 0.4566. Close parenthesis and hit enter. Now you're going to end up with a negative answer. So if you simply add 360, you'll find your first answer. If you take 180 minus that answer, you will find the second one. Let's see how you did. Start with the arc sine. I recommend that you work with the word arc sine. Don't use the -1 power. A lot of people get confused using it, and I don't want you confused. This is what we start with. We're going to get a negative answer. So we do second function sine of negative 0.4566, enter. You should have gotten negative 27.1679 degrees. We are now going to find the fourth quadrant. Simply add 360. There is our first answer. Now, if I'm doing this, I'm going to go second enter, second enter. Notice it takes me back to where I can evaluate. Hitting enter, I can now do 180 minus that negative answer. And when I hit enter, I have both solutions, 332.8320 and 207.1679. And I'm going to write these down as my two thetas. Theta 1, once again, it's approximate, 332.8320. And we make sure we use our degrees. Theta 2 is going to be 207.1679 degrees. And what I want you to notice is just this general process. Next week, when we go to radians, you're going to have to do it with radian values, and it's the same thing except we're working with pi and 2 pi. All right, instead of 180 and 360, we're going to have pi and 2 pi appropriately. Let's go ahead and do another one. This time, let's go ahead and do the cosine theta equals negative 0.8332. Now, keep in mind, I've given you a cosine. This is from the previous video, the video that you should have watched before sine. Now, if you haven't done cosine yet, I recommend that you go and watch the cosine video. After all, cosine is now going to have a different arc than what we've seen. Our cosine starts at 1, goes down, goes through, goes back up again. This is a cosine. If I were trying to graph this cosine, it also has a problem, because if I try to graph it, it starts at 1, which is about here, goes down and then goes up, down and then up. And once again, you'll notice it fails the vertical line test, so we restrict the domain, and we only work with these two. If this is pi over 2, it ends at pi. And we're now looking at quadrant 1 and quadrant 2. All right? So it'll always give me an answer for cosine, which is why we like cosine. All right? I don't have to do anything to it, regardless of whether my ratio is positive or negative. But what we do have to do is we have to watch out, because our cosine is negative in the second and the third quadrant. Make sure you can see that. The second and the third quadrant. And because cosine is negative in the second and the third, but the calculator will only give us an answer in the second quadrant, we will have to first find our reference angle, and once we have our reference angle, we will have to make sure that we add 180 degrees to it in the third quadrant. Once again, that comes from this idea of the reference angle, 180 plus theta prime. Let's go ahead and do this problem now and see how it goes. We do second function cosine. That's the arc cosine. We're going to put in our decimal, negative 0.8332. We know we're going to get an answer, and that answer will be in the second quadrant. See how it's between 90 and 180 degrees. It is definitely in the second quadrant. That's my first answer. So I'm going to write that answer down. This is theta 1. Theta 1 is approximately 146.4288. And make sure you include degrees, or it will automatically be thought of as a radian. Alrighty, now I'm going to have to find my reference angle. So I'm going to take 180 minus my answer, and I have my reference angle. That's 33.5711, and I'm simply going to add 180 degrees to that reference angle. I then get my second solution of 213.5711 degrees. And I'm going to write that down. Theta 2 is approximately 213.5711 degrees. That's working with cosine. So that's sine and cosine. And I hope this helps you to figure out your ratios, or finding the thetas and degrees that will give you those ratios. So once again, what's different from what we were doing is we did have a ratio, and we used that ratio to answer our questions based upon the unit circle. We now don't know what the angle is that is giving us these different ratios. And we have to first find what those angles are. And these angles are not going to be on the unit circle with our 60, 30, 90, 45 angles. They're always going to be different. And we know that because this is not the root 3 over 2 or the 1/2 or the root 3 or the root 3 over 3. So we can clearly see this is not exact. This is not on the unit circle, and therefore we have to go through this process. Alrighty, that was sine. I hope this was useful to you. If you like this, please remember to click like. If you have suggestions or you have concerns, please make sure you put them in so that I can try to improve as I go along. Thank you very much, Hornets. On the next video, I will be doing arctangents. Thank you, be well, take care, and have a very, very safe weekend. Bye-bye now. Cheers.